This is a fully adaptable model with a touchscreen interface to allow for fast adaptation, allowing for 3D sketching but still having the full parameters of a contextual model, the right thickness, the right size, and the right proportions. So there's different menus here. We have the setup menu, different briefs here. We'll go through that later. This is the dome and 2-surface design. There will be different models added, a 3-surface, monopod, etc. This is the head form page. This allows the setting of a head form and a testing line. It allows for, just toggle off the preview, go back to the head forms. It allows for establishing the thickness, base average thickness, and then an increase in thickness on the top sides, or tailoring the X, Y, and Z thickness profiles. When you go with foam sim, that shows the foam that's required underneath the testing area, and that can then be compared to a rendered model and see where the discrepancies are, see where it needs to be adjusted to cover and meet the minimum thickness. This can be sort of fudged in the beginning to allow for shape exploration, but that exists if you want to dial it in. This page handles all the top profile, which is shown here. This adjusts a couple different points on there. This is a point in the back, the angle and throw of the back curve. So this dial right here shows the throw, which is the amplitude of the curve leaving the center line. Turn that down, and the helmet tapers down to almost a point. The angle in the case of the end is always, or in this case is always 90 degrees, but that can be a very blunt back end of the helmet, obviously too blunt. You can see the shape change up on the top is instantaneous. It's a very blunt back end. We'll look at that as we adjust this section here. Control the amplitude down a little bit, and then there is a indicator which shows the magnitude of that, and a visual indicator. All of these dials have an inner and outer dial. There's some different experiments going on here with the UI, but this is the outer dial that controls the angle. This may break the definition, but we'll move the angle a little bit. Puts a little bit of a peak in there, and the other controls the throw. That's not very nice, but that's kind of what's possible. The nice thing about this program is that it really keeps really tries hard to keep the surfaces. That's a single span surface. We can look at the points on that. Turning this on, you can see the points, the control points. Fairly heavy in definition, but the nice thing is that this all controls the major factors. So we'll put that back to 90. We'll bring that in just a little bit, so there's a little bit of a point there. And we'll adjust. That looks like a good shape right there. And we'll turn off the points just for visualization purposes. Okay, as we said, there's the dome, which is on the top, and the bowl, which is on the bottom, the surface. We'll preview both of those. There's the bowl surface that the helmet's cut out of. So there's a dome surface and a bowl surface, which is shown here. Preview dome, dome surface, bowl surface. Those are the lines with the cut lines. Some different terminology here. This is the crown line. That is handled on the dome page. All of these factors on this page, the dome surface page, are controlling the dome, obviously. This turns on and off the dome line. This lets you see the curvature. This adjusts the scale of the curvature. And in the middle of this control is the indicator for the pin. It's called a pin, basically, but it's the control of the Bezier curve that controls that surface. So to increase the throw of that, that's the inside line. That pushes this whole helmet out. Also changes, you can check at any time, the effect on the 3D surface. Remove that throw a little bit, and the design changes instantaneously. This is a nice, this is the view, the typical alias surface view. This is running in Rhino, obviously, but this is the alias surface shader. There's also a lot of controls over materials, so you can change any of the colors with one touch on the interface. Just kind of examine it in different colors. Some flat grays, also some quite shiny reflective materials. Sometimes, if the mesh settings are really low, you can see some roughness in the surface. I'm going to crank down. This right here controls the mesh settings in Rhino. Go up here, check it. You can see a little bit of faceting. See the faceting in the curves, and that makes analysis a little bit difficult. So this allows you to crank up for a little bit at the cost of speed. Crank up the definition of the mesh, and it gets very, very finely meshed, so you can see the aspects. In addition to the different kinds of rendering materials, there's also a zebra-esque isophote display. This allows for seeing the curvature. It's not exactly like a zebra, which always rotates according to the view. But this shows the actual curvature of the shape, distancing of the curvature, where the spaces in between the lines are wider. That's a flatter curvature. You can tell the evenness of the set of lines as it goes across. I'll do some adjustments now with this in place. Again, as with most things here, the scale of the curvature can be changed. The angle with one dial, so on and off is toggled in the middle. Scale of the curvature display is controlled here. Bump that to something in the middle. And the angle which that's being viewed at is controlled with the outer dial. So that rotates this whole shape down to the back. Just looking at it there. Also, this design is not aiming towards tangency at the moment, but you can also check on tangency of a curve in general, on how the lines are lining up. Belt line curvature is not controlled for tangency at the moment, but it is fully capable of doing that. Rotating this down to the front spins that around so you can take a look at it from the front and analyze the different aspects of the curve. It's a very literal way of looking at the curvature. We'll bump the meshes down a little bit back towards the middle, and we'll turn off the isophote display. Alright, we'll turn off also the comb. Okay, the comb magnitude can be controlled there, as we saw before. That lets you sort of adjust the curvature of the middle of the line. That indicates the magnitude of the curvature. So if you feel like there's a little bit of a flat spot there, you can go through and just give that a little bit of a boost. Too much of a boost. These dials are also quite nice because if you drag on a dial and then go and don't have the minute control, you can drag your finger off the surface and have a much finer control of the angle out over the edge. It allows for quite fine adjustments. Alright, we'll turn the hard black display on here. We'll turn off the display of the front pin, display the curve, and we'll turn off the curvature. Sideways in the helmet, it's nice to be able to control the side curvature. But in the front we have latitudinal curvature. So let's turn that on right here. We have a front curve. We'll turn the crown line back on as well. We have a front defining curve and a rear defining curve. So this controls the latitudinal curvature of the helmet. This is the front curve, this is the back curve. This controls the placement along the shape. That moves it to the back. This moves it to the front, so you can have different control in the front. At certain points in time, the definition will break, but that's fairly rare. It always can be tuned up later. This now is here, and additionally, this is locked in the middle by the lock icon so that the front, the top, and the rails of the curve are traveling together. But if you want to angle that down, you can control the front, move that forward, move it back, or lock it together. Okay, we'll keep that locked together for the sake of a nice demo here. Now, the control of the curvature. So we can turn on the pins here. This is the visualizer. In the center of all these buttons is the part that it's controlling, the visual representation. We'll turn off the preview for the moment so we can get a nice clear view of that pin. It's the crown A pin, and this adjusts the magnitude of that curve, changing from a very flat profile to a peaked profile, with nice curvature being approximately in the middle. And this can be done. It's just a little bit to see this pin, which doesn't show well when it's rendered. This can all be done when it's rendered as well. So we go for a flat curvature, very flat head shape as seen in the front view, dialing back, dialing back. Due to the slight lag in Grasshopper, there's a little bit of a penalty for moving continuously, but it's also possible. The most square of all is by controlling, so this controls the crown out, this controls the rail up, which is visible here, this line right here. Turn the, this line right here controls the throw of the curve up. We're going to amplify that very hard and get a very square profile. Let's see if that'll render. And yes, it does render a little bit messed up, but there we go. All right, let's get back to a realm of possibility. This can be balanced back and forth between the front and back curves. Sometimes can be done for meeting. Look at the back curve now, again, boosting out a little bit more square. Tapering in from the side, we're going to taper in this way with this angle right here. That tapers in a bit of a kick. That can be very aggressive, which gives a concave, an actual concave to the surface. Let's visualize that with the isophoto display. Now we see the kind of curvature that's happening there with the control lines. If you were to go entirely negative again on the back, you would have a concave section. So let's just try that for a second. Oops. Ugly helmet, but sort of the fireman look there. That's what happens with the curvature display when it goes concave. Actually cut through, you can see right there, into the inner shape, the inner headform surface. All right, let's bump that back out again. Let's get that to a nice degree. Move these back to near vertical. Everything's updated. See the curvature there. Again, we can move this back almost to the end of the helmet if we want control over that back surface. Turn off the display of those here and here. Alright, that's showing the so now this zone blends between those. There's a magnitude surface display, magnitude surface on a dome. I take that back, that's not hooked up right now. Alright, that's showing it's broken the model right now with the magnitude of this driver. There's a magnitude along the rim of this surface that's controlled here. And at certain points in time it does break the equation. Let's see, we're going to go to magnitude surface and off. Okay. 0, very good. Alright, back in business. There's different controls now. There's controls on the cut line of the helmet. This obviously is the cut line of the helmet. Turn off the display there. We'll go back to Nice glossy display here. Turn off the crown line. Also, we have the crown and we have the bowl. The bowl is designed to be almost the same as the crown. The controls are there. This controls the front lateral curve, rear lateral curve, and the overall bowl profile. So if we want to see the belly line, which is the bowl line, right there, that is the bowl line, and the resulting curvature graph along it. The latitude curves are there. We control the shape of the lower surface of the helmet. Again, they can be controlled exactly as the top. Now, if we like this helmet, if this helmet is looking good for us at this moment, we can go save it into the library. Save it into an open slot. We go to the library. We hit record, grab a slot, and then we confirm entry into that slot. And now that helmet is saved into that slot. There will be indicators later, but these are all the slots. So if we want to load a pre-existing helmet, this is more of an aero bike shell. That loads in, that's in real time. It takes about 2.5 seconds to load in a design. We've got all different kinds of helmets here, all different kinds of profiles and cut lines, some burn-esque high belt line designs with different cut lines. This cut line on the bottom here is variable, and the shape we've just recorded is there. That's the shape we put in before. Now, one of the nice features, let's turn off this belly line that's sticking out of his chin. Go back to the bowl surface, turn off the curvature, turn off the lateral curvature, lateral curve display, and examine the possibility of blending between two shapes. So, let's go to the blend page. Grab a helmet in, let's turn on the mixing button right there. It goes to the first shape that's in the library here. We can set the curve that we just had, the shape that we just had, which is the shape we were working on. We can load in a pre-existing shape into the B deck, A deck and B deck. We can slide over all the way 100%, just like in a DJ mix, shape A, 100% shape B. It's a pretty subtle difference in shape B, but along the way are the variations in between. And that looks like those two have an identical cut line, because I suppose we were modifying that one before. Let's go to a different shape B, and all the way over to shape A, all the way over to shape B. Quite a bit different. Got the gazoo head shape going on there. It's pretty extreme. So we're going to back out of that a little bit, shape that's halfway in between. Let's go to the burn shape. The burn shape, I believe, was there. Okay, a burn-esque shape with a high line, a little bit like a sparring helmet or something like that. So now we have blending between these two. A and B. 25% A, 75%, 25% B, 75A, 50-50, and everything in between. Now that's mixing all of the factors together. If you were all over in A and you just wanted to mix the profile could be mixed here. That's just mixing the profile. If you wanted to just mix the outline shape, which is here, the outline can be mixed only. Combinations, again multi-touch, so no problem, a little bit of each. And cutters, if you want to move just the cutters. Now let's say we're let's say that for the sake of discussion, this is in the ballpark. We do the mix, we hit the mix button, mix down. So this is going to mix down so that we can manipulate it into the current model. Okay, that's now in the current model. We can go to the dome page, and the individual pieces can be adjusted. Get in here and adjust out the squareness of the top curve. Everything is now live and adjustable. Let's go out a little bit. Square was a little bit nice. Nice looking form. Let's move that control a little bit forward. All right. Not aiming for tangents here. Now there's the control of the profile band line as well. If you look at the side, this right here, this curvature right here is called the band line. We're going to go there, profile band. This controls the spline that goes across that band. So if you want to increase. Alright, just looking at a few other things on the interface right now. We have along the bottom edge, which is visible here. The bottom edge are different shading profiles. So instead of, it's designed to operate everything that's most commonly used from the palette. So we have wireframe views, shaded view, render view, nicer display here. It's a nice pen display. Let's go to a more solid material. There we go. That's back. All right, now, the purpose of this tool is to be able to use an iterative hand approach. My experience has been in using clay models. That's really the most luxurious way to explore a shape, which is very slow and requires a lot of money for a client to get it done. So that's fallen drastically out of favor. With the ability to 3D print models nowadays, these models can be generated very rapidly, especially when you're dealing with a model. You know, this is a closed model that can be baked. It can be baked with this button at any point in time. There's a lot of process before, though, in determining vents, structures, and different things that takes place before, and that all takes place in 2D drawings. So what you want to do is have something that you can sketch on. And what I've always done is project various flow lines onto the surface of a helmet, and then sketch on those flow lines where the vents, ribs, structures, cutaways, layers of onions that are going to be carved out, revealing surfaces underneath them. That all takes place along what I like to call the flow lines. We have a button here. It's Flow Graphics. Hit Flow Graphics. Flow Graphics have two choices, ribs and rails. This is rails. They run front to back on a helmet. Ribs, crown to band line. This takes a look at the surfaces and lets you control a set of sort of graphing lines. We'll turn these on, some graphing lines here on the rails. That shows the graphing lines. Now you can have as many as you like. And you can control the flow of those lines across the surface. So we'll take all those, we'll wipe them out. We'll put in one every third place along the curve. All right, there. The spread of those lines can be controlled. So they're quite tight at the front. The sweep of them across the curve can be controlled so they stay on one side or the other. This updates, we'll go to a little bit larger view here. Front and back flows, let's move the sweep of those curves across, and the spacing. So we extend it out across a large range. They move along this curve, so we can see on the top. Those are the rail curves. Curvature of the back, rear center curvature. Curvature of that line updates. This allows you to examine a flow that you think might look nice with this helmet. We'll increase the front rail sweep there just so it's a little bit more along this line. Change that front angle. A little bit too much. We'll drop that back down. We'll bump the throw out a little bit there. This is controlling a set of Bezier curves that are projected onto that. You can also look at the pins. These are the pins that are driving it. They appear along here. That lets you visualize the angle of what's throwing the curve and the spread of them. So if you add more pieces in there, you get more curves. This is rails. I'll turn off rails for a second. That clicks off there. We move to ribs. These are ribs. Let's turn on the ribs. Ribs flow from the top crown line. They're ribs like the ribs, rib cage ribs. Ribs and rails. Let's knock out some of those just for brevity of definition. All right. These curves as well are able to control the overall range of those, the spread of that set of curves, and the placement along the curve. So let's move those a little bit forward. Again, the angle is controllable. That wouldn't be used, but that might be used, and then the rail along the edge there can be controlled as well. This curve right here. Let's turn the pins to visualize that. Actually, these pins are only half working right now. A set of gradiated color pins. The gradiated color pins, just for visualization, the thickness is controllable here. Thickness of that curve and the amount of color mix. It's not entirely a settled solution now. This is designed for printing out worksheets to draw the graphing onto. And bring those back in, turn the pins off. Ribs and rails together, we go to rails, turn on the lines, move the thickness down, and we get a set of lines that can be drawn, that can be printed out, sketched over, and worked with. All right, let's turn those off. Good, that's back to the blank definition. Let's see, a little bit too pinned in the back. I'm going to go back to the top outline. And I'm going to throw that curve out, this right here. That widens it out. This line right here, keep the angle at 90 degrees. That's a little bit better. Okay. Different colors again. Turn off the lines. Again, of course, it could be viewed without the head mesh. Let's just turn. Let's see, crown line on and off. Some of the toggles have to be toggled on and off to get the piece out. UI work to be done. All right, then let's turn on the belly lats, crown lats. Off and on, toggle off and on. Look at the inside and outside. These are all, the inside is a single span, bowl is a single span, dome is a single span. It is a complete, integrated, watertight part. Can be 3D printed for testing and sketching on. The idea of this all is to get a model that can be iterated on quickly with a minimum contact to the intricacies of the parametric model. Next step is the cut line. Okay, this is probably the more complicated of the definitions. This is cutters. Profile cut lines. Now we have different sections along this helmet, so let's just deal with the terminology here. We have the brim, the temple line, ear cove, and the quarter panel in back. Each of those lines can be turned on to show you where in this model where that ratio is, where that temple tab is coming out. That can be moved forward and back. This is all saved with the definition so they can be blended between. Also, they can be aggressively cornered, which they currently are. They can be smoother, which is this location, which is this setup. Let's turn that off. The length of that tab can be increased here, so that comes down. That's ridiculous. The width of it can be increased. The ear cove, that shows the white line right there appearing. That's the location of that. Can be pushed forward and back. Again, also adjusted for width. The ear cove width. Let's go back to the hard definition, and overall it can be also completely smoothed out like in a bike design. It's very, very smooth. Again, the ratios have effect, so that ratio can be moved forward, back, and bumped up to reducing, smoothing, back up to a more conventional definition. You want a very subtle temple tab, that's moved up. And for the hard designs, with a corner design, each of these radiuses here can be controlled. Let's move that, let's move this back a little bit. Make that temple tab a little less wide. And we have control over all the individual radiuses. I'll set them all as sharp as possible. Alright, so basically the flow of the curve goes from the brim to the temple, to the ear cove, to the quarter tab, to the rear height. That's the way the system works. Alright, if you want to just radius that right there, that radius gets bumped up here and adjusts. Again, ear cove radius, temple tab radius, and ear cove radius in the front. This can be moved forward. That would that would limit vision, and back. Alright, these definitions can be saved as well if you want to go down. This lowers down, but it has the effect also of bringing down the ear cove. So we might want to just move that ear cove a little bit more forward. That's not looking bad. A little bigger radius there. Right in there. Okay. That's looking good. So that's definition. There's a peak, the Grasshopper definition inside. We'll blow that up for a second. Yeah, that's what's going on. Minimize. Grasshopper and Rhino is a wonderful thing. Appreciate all the work that McNeil's done on improving Grasshopper for version 8. And we're looking at helmet. All right, that's the intro of the helmet shape toolkit for today, which is June 29th, 2024. Thank you. As many suggestions or feedback, I would be happy to hear them. This is designed not as a solution, but as a tailored platform that can be modified and tailored with different head shapes, different head forms. All of the head forms in the library are completely user customizable. The blend extremes can fit into a piece. And as well in the setup, we are going to different more aggressive designs, motorsport, full face, extended aerospace, sci-fi options. And there's a lot of ways to tailor this topology to helmets. All right. Thank you very much. This is Shaw at Stratospheric Industries, signing out.